Welcome to Anywhere Math. I'm Jeff Jacobson, and today we're solving inequalities using multiplication or division. However, there will be no negative numbers in this video. So with that, let's get started. Okay, example 1. Solve x over 5 is less than or equal to 2, and then graph the solution. Well, solving inequalities using multiplication or division is just like solving equations with multiplication or division, as long as you're not multiplying or dividing negative numbers. And in this video, it's all going to be positive, so it's going to be like the same. It's going to be just like doing it with equations. Our goal is to get the variable alone. Right now, x is being divided by 5, so I do that inverse operation and multiply this side by 5 to get that x alone. And anything I do to one side, I have to do the same to the other side to make sure the inequality stays true. So here we go. X over 5, if I multiply this side by 5, less than or equal to 2. Do the same thing on this side, multiply that side by 5. Those 5s will cancel out, and I'm left with x is less than or equal to 10. Okay, I've solved it. Now let's graph that solution. Here is my quick number line. I know x needs to be less than or equal to 10. So maybe here's 0. There is 10. Less than or equal to, because it's or equal to, that means my dot needs to be like that. Filled in, arrow, going towards the less than. Here's example 1. Here are some to try on your own. Okay, example 2. Solve 4n is greater than 32 and then graph the solution. So same thing. I'm trying to get the variable alone. I notice n is being multiplied by 4, so the inverse operation of multiplication is division. Dividing by 4 will undo that multiplication, and then I do the same thing here. So 4n is greater than 32. I'm going to divide this side by 4, which means I'm also going to divide that side by 4 to make sure the inequality stays true. Those get canceled out, and I get n is greater than 32 divided by 4 is 8. Okay. This represents all my solutions to this inequality. Any number that's greater than 8 would be a solution to this inequality. So let's graph that. Here is quick little number line. I'm going to be at 8. Let's say 8 is here. Let's go 8, 9, 10, something like that. At 8, because it's greater than, it's not greater than or equal to, I'm going to have an open circle, and greater than, which means the arrow's going to the right. So again, this arrow represents all the solutions to this inequality. Any number that's greater than 8 would be a solution, right? 10 would be a solution because 4 times 10 is 40. That's greater than 32. 9 would be a solution. 4 times 9 is 36. That's greater than 32. A million would be a solution. Anything greater than 8. Let's try one more example. All right, example 3. A one-day pass to a gym costs $4.50. A 30-day pass, or like a month-long pass, costs $45. So part A, write and solve an inequality to find when it's better to buy the one-day passes instead of buying the full month-long 30-day pass. So this is very typical, right? New Year's resolutions, people say, okay, I want to go to the gym. Well, is it better to buy the month-long pass, or is it better to buy or to pay each time you go? Well, it depends on how often you go, which is exactly what we're trying to find out here. So let's look. A one-day pass costs $4.50. The month-long is $45. Now, the one thing we don't know is how often we're going to go, how many days we're going to go. That's going to be our variable, right? Whenever you're writing inequalities or equations, always think, what's your variable going to be? What don't you know? And in this case, we don't know how often, how many days we're going to go to the gym. So that's going to be my variable. I'm going to call that D. D for days to the gym. Well, each day costs $4.50, so this will become 4.5D, right? 4.5, $4.50 times the number of days you go. Now, what we're looking for is when it's going to be cheaper, right? When it's better to do the one-day passes. And it would be better when this cost is cheaper than the $45, than the month-long. So to show that this is cheaper or a better deal, we would make it less than 45. Okay. So take a second and just look at that and think about what we wrote. So what we're saying is $4.50 times the number of days, right, is less than, if that's less than $45, which is the month-long pass, this would be the better deal. So now let's solve it. So we wrote the inequality. Now let's solve it. Divide both sides by 4.5 to get that D, that variable alone. D is less than, well, 45 divided by 4.5 is 10. You can do that over here or just trust me. What that means is, when is it better to buy a one-day pass? Well, it's better to buy a one-day pass if you go less than 10 days. So there is our answer. Let's try one more. Okay, same problem. We're just going to do part B and part C. When would the cost be equal? The cost would be equal if you went exactly 10 days. Right? If you went 10 days, 10 times $4.50 would be $45. If you went 10 days with a month pass, well, it's still $45. And last one, when would it be better to buy the 30-day pass? Well, if it was cheaper to buy the day pass if you went less than 10 days, and if you do exactly 10 days, it doesn't matter. Well, then if you go more than 10 days, the 30-day pass would be the better deal. Because after every day above 10, it doesn't matter. You don't get charged anymore because it's just a $45 a straight fee. No matter if you go 11, 12, 13, if you go 25 days, or if you go all 30, right? That would be the better deal because if we did 30 days and paid $4.50 each day, well, 30 times 45 is going to be much greater than 45 days. Okay? Here are some to try on your own. As always, thank you so much for watching, and if you like this video, please subscribe.